In this video, I go through the basics of using Bazel build. Bazel is an open source build tool developed by Google and is used by many of the biggest kind of software projects in the world and some of the biggest kind of tech companies in the world. So I started using Bazel a couple of months ago, and I don't really have a very strong background in programming. So it's taking me a while to just understand the core concepts of Bazel and understanding how I can use it effectively in my own projects. So I decided to make a video that shares kind of my experience now that I've kind of gotten the basics down. And this is basically the video. This answers most of the questions that I had when I was starting out. So in this video, I just make a simple Bazel project. We create a really basic build action that doesn't depend on compiling or anything like that. We just make a build tool in Bazel and we show how that works. We define inputs and outputs, and by defining the inputs and outputs, we actually leverage one of the most powerful features in Bazel, which is being able to detect if something has changed in the environment and then only build or run the actions that are needed. And at the end, we add a dependency on an external tool that ensures that our build action is buildable on any machine and basically in any operating system. So I'd love to connect with more people who are working with Bazel or want to use Bazel in their own projects. So definitely, if you enjoy the content, leave a comment and subscribe to the channel. So other than that, just let's go. All right. So I like to start when I'm testing things out, just to add the Bazel executable into my project. It just makes sure that like I always know that where I have it, and I don't have to depend on the environment to have it installed somewhere. So when I'm trying things out, I'll just copy paste the file into the project. So you can see here I have Bazel exe. So let's start by clearing this, and let's just start by making the basics of the project. So a Bazel project needs a workspace, a workspace file, and we can leave it empty for now. The workspace file basically just tells Bazel that this is the root of the project that we're working in. All paths are relative to this workspace, and inside of the workspace file we can load dependencies and register tool chains and do all sorts of cool things once we've gotten the hang of the basics. We also need to create a build file, and the build file is basically where we define the actions or the build actions that are available in this project. So now that I've created a build file, there's nothing in it. I've also created a workspace file. We have the most simple Bazel project that you can make. So I'm just going to run bazel.exe build, and I'm going to do semicolon. So basically I'm going to do 2 slashes and semicolon, and the 2 slashes mean root, and this is going to be then relative to the workspace. And because I did the semicolon, that means that this is a package, and the package, all of the actions that are available are inside of this build file here, and I can just say all, and this means that it's going to build all of the files that are available inside of the build all of the kind of targets that are available inside of my at this location here. So as you can see, it analyzed 0 targets because we don't have anything in our build file. Found 0 targets. Great, this is what we wanted. But the important thing to notice here is that when I ran this, we got a couple of these folders symlinked into our project. So we have Bazel bin, Bazel out, another Bazel out. We have this is just a bunch of folders that right now don't have anything in them. So this basically is the kind of environment where Bazel is running our commands, and it's going to make a lot more sense. It's going to make a lot more sense a little bit later. So I'm just going to quickly jump over to this file here. Yeah, all right, here we go. So basically what we've done now is we've created the simple Bazel project here, but we want to do something interesting. We want to do our own build step. And the key here, and when I'm learning this, and when I was learning this, the thing that I had the most trouble with was everything was kind of so focused on if you're using a C++ compiler or a Go compiler or something like that. I basically just wanted to do what is the most simple thing that you can do without having to worry about all of these other tools. I can add these other tools just based on the projects that I'm working on, but I just want to understand how Bazel works. So what we're gonna do is we're gonna make our own custom rule here. So I'm gonna make a new file and I'm gonna call it my custom rule.bcl. So a rule is basically something where it's basically an instruction. It's a function that tells Bazel how to perform the build itself. Like, it doesn't actually do the build itself. I mean, it uses tools and things like that to do the build itself. But this kind of describes the action that is going to be done. And how it's executed, what files to watch, for example, to determine if this should be run again, if some of the inputs have changed, or things like that. So we need to make a rule here, and let's just start by making an ultra simple rule. So I'm gonna say I'm gonna do a rule called write new file, and I'm gonna do this is a rule. And the rule has one, I think this is the only property that we need to say. I need to kind of define. It's called implementation. And implementation is going to be the function that is called. So we normally, I don't know if this is required, but at least the convention seems to be that the implementation is the name of the rule, .imp. Okay, and then we need to define the actual implementation of the rule, and then we do def, and we take this here, and we do ctx. This is required. This is the kind of the context that is then passed into it. We're going to be using this a little later, and now we do pass. So this is the absolutely most simple rule that you can make. I'm not even 100% sure that it's going to work, but it's just you define a new rule and you say that the implementation for this rule is in this function here, and it's defined like this, and it doesn't do anything. So this is our absolutely kind of basic rule. So I'm gonna check this here. Now we go back into our build file here, and the important thing, what we want to do here is we want to use this build rule, because if you see that when I press, if I type, for example, here Bazel build / I want to use my rule here. I just made a rule called the write new file, but I wanna use this rule somehow. And to be able to do that, I have to define this rule in the build file of the project itself, or in this package. And the way to do that is we run load, and we need to tell the build file where to find this custom rule. So I'm going to do / for root of the workspace, and then I'm going to say semicolon, because this is a package. And it's a package. The reason this is a package is just because there's a build file here. If there's a build file in the folder, then Bazel treats it as a package. So I'm going to do / for the root directory. So I'm working in this directory here, and there is a build file here, which means that we're going to do there's a path here, there's a package here, and then we just use the name of the file, my custom rule.bcl. And then we do comma. The load command also needs to know the name of the rule that we're importing. We do write new file, and that's basically it. Now we've loaded the build file into loaded the build rule into our build file. Now we can use it. So I'm gonna do write new file. So I'm defining a new. I'm creating a new build action, and it's using this rule here. So I'm going to give it a name, and this is going to be write my custom message into file. So it's a bit of a long one, but yeah. So now I actually have an action here that is called write my custom message into file. This is the name of it, and this is the function that is being used. So now if I go in and do build all, you should see, this is probably nothing happening yet, but because we haven't finished actually setting everything up inside of the rule here. But what we've done here is we've defined the most kind of simple kind of project that you can make. We have a workspace which defines the root with nothing in the workspace. We have a build file that loads a custom rule from here. The custom rule is not doing anything. It just has an implementation here and a definition, and then we create an action, a build action in here, and we call our build action write my custom message into the into file. All right. So these are the absolute basics. So now we can go in and we can actually make our custom rule do something a little bit smarter. So write new file is going to take in a file. So the intention of this is it's supposed to take in a file that we have. So let's just go ahead and create our new file. So let's call it my input file.txt. So this is my input file. I hope it gets through safely, gets through the build process. Like so. So now I'm just making just a text file here that we're going to use in our example. So we'll take a look into our custom rule again. So we want to use this file here. We want to pass this file in here. We want to copy the contents of this file, and we want to write out a new file that has the same contents as this one here. And that means that we need to pass this file here, or pass a file into our build action. And the way that we do that is we add another kind of property here called attributes, or attrs. And this is going to be an array, or not an array, but struct, I guess. And let's make an attribute called my input file, and so this is so it's like a Python dict. So my input file is an label. So basically what I'm just doing now is I'm saying in the definition of the rule that the rule has an input or an attribute that it can take in, and the attribute is called my input file. And my input file, this attribute is a label, and I'm going to say allow single file equals true, which is going to allow me to pass in a file. So now we've added the single file here into it, but let's just keep extending or just kind of flashing out our custom rule now. So first thing that we want to do is we want to write a new file, and we do that by defining the output of the function itself. So this is one of the things that took me a while to figure out, and kind of one of the core things about Bazel is that these build rules you need to be very kind of explicit on what goes into the function and what goes out of it. And the reason for this is so that Bazel can figure out, do I need to rebuild this, and things like that. So because we're writing out a new file, I'm going to do ctx for context here. There's an actions function, and we're going to do declare file. And we're going to be just declaring a new file that is going to be output out of this. And I guess we would want to have our users be able to specify the name of the file. So let's add another attribute here, and we're going to call it out file name, and we can do attribute string. So this is going to give us, this is going to allow the user to pass in a string, and the string is going to determine the name of the file. So we have and this is another thing that took me a little bit of a while to figure out how to do. So here we need to use the ctx object. We need to access the attributes kind of data. So we do that by doing ctx dot so this is a string, so it's going to be under the attributes. And then we just use the name of our file here. And then because this is a string, we can do .txt. And now we have now we've created a file that is just a name that is going to be passed in .txt. And because we just declared a file, we can say output file equals this. So effectively what's happened here is that when someone uses the write new file rule, the only thing that happens is that they need to provide an input file, which we haven't used yet, but they also need to provide an output file name, which is just a string, and the output file name is then used to construct the name of the file that is going to be outputted in our rule. So let's see if this works. So now we've already, if you go back into our build file, we've made some changes to the write new files rule. So now we also need to provide an input file. So let's just add that here, input file equals. And again, because we're working within our workspace, we say root of the workspace inside of this package here with the semicolon, and we say my input file.txt. So this is going to reference this file here, and it's going to pass it into the rule. And let's see what we call the output file name property here. And output file name is going to be my awesome output, like so. So let's see what happens if we run this. And I'm not 100% sure this is going to work. So I'm taking the I could pretty easily just do all, but what I can do is I can do Bazel.exe. I'm going to do build, and then I'm going to do semicolon, because this is root from the root semicolon, and write my custom message into a file. All right. So we're getting some errors here. My input file is not defined, and output file is not defined. Okay. So let's see what's happening. This is because I didn't do it like this. Here we go. I think, yeah, okay, cool. Yeah, so I was just, I got some, like someone told me that there's probably a good idea to have like a linter, yeah, basically this is supposed to be a string, because I'm actually making a dictionary of attributes here. So let's clear this and take a look at the error that we're getting. So the error that we're getting is the following files has no generating action. So my awesome output.txt. So this means that we've made a rule here. We've defined a file. So the file is being defined, but we're never putting anything into the file. So there's no action that is actually generating any output into this file. So now we basically do that. We do ctx.actions, and we do run. And the run action, let's see, it takes a couple of arguments. It takes outputs, and outputs is an array. And the outputs is the file that we're going to be writing into. So let's do it like this. So right now we've created an action, and we've said, okay, so this action is going to return. It is going to modify or create or change in some way this output file that we created. And this is what Bazel was complaining about. We're going to do executable because we need to do something. So Bazel doesn't really do, so we basically just have to say, we have to tell Bazel, okay, so we're going to run an action. This is what's going to come out of it. And then we're going to have to tell it, so here's the tool that you need to use, or things like that. So for now, we're going to do cmd.exe. We're going to run just the Windows shell. And let's add arguments. And here we can do the arguments. So the arguments that we're going to be running here are this took me a while to figure out. So I'm going to do, the first argument is going to be this argument here. And what this does is that it tells the command line or command prompt in Windows to exit after it finished the command. Otherwise, your build step is going to hang. So next, we're going to use a command called type. And I had to Google this before. The next thing that we're going to be doing, so basically we're constructing a command that is going to take the input file that we're passing in, my input file, and we are going to be copying the contents of the input file into a new file. So the third is going to be the input file itself, because we're copying from that file. So now we have to access the input file. So because this is allow single file, the label here is allow single file, what we can do is we can go into ctx dot file dot my input file. So then we have the file object, but we want to get the path of the object because we're constructing a command. And one more command, we do this here, and the second and the last one that we do is we do the output file dot path. So I am not a huge fan of build tools like this, but this was kind of the simplest thing that I could figure out. So let's see if something works. What's going to happen now? So we have an output file. We don't have an input yet, so we'll cover that in a little bit. But we have an output file, we have an executable, and I'm just assuming that CMD is available on this machine, and we'll tackle that a little bit later when we upgrade this logic a little bit. And then the arguments are this thing here. So we run this, and you can see that I'm getting green text. Always happy when I get green text. One target, write message, nothing to build. Okay, so that's a little bit annoying. So it does this. So the rule itself has an output file. There is an action, and we say the output of this action is here, but nothing is actually being run. So if we check Bazel out, for example, and we check the folder where this is supposed to go, the binary folder under the Windows Fast Build, nothing is happening. So, and the reason for that is that our rule is still incomplete. We need to return. We need to return a special type of structure that tells Bazel what file actually and what file or files actually comes out of this rule, and we do this with something called default info. Default info. So the default info is what's called a provider, and basically what we need to do is there's a bunch of things. If you're returning an executable, you can do that inside of this default info object. But what we're going to be doing is we have we want to set the files kind of field here into. Let's see if this works. So we're returning just a single file. So if you run this now, so files want a special type of kind of data set or data structure called dep set, and this is the way it's supposed to look like. Right, so we create the default info object, and we say that the files part of it is a dep set of the of output file. So this is just a special data structure for. I haven't really used them very much, but this is what it needs to be. So now you can see that I have my now that I run it. If we go ahead and take a look at this. We run this now. I'm gonna do clear. Okay, so the problem here now is that because I was running this a bunch of times, the build rule itself doesn't really know. The build rule itself doesn't really know if something has changed, so it's just assuming nothing has changed. I'm not gonna give you anything. Like everything is fine. So let's run Bazel clean, which just cleans the whole environment, And let's run this again. Bazel exe build and then our custom rule here, or our custom action. So here now, because we created this, let's see if this isn't here. Yeah, here we go. So now you can see that because I cleaned this, the problem was that it didn't really figure out that it just thought that yeah, like I've already built this, I don't need to worry about this. So even though I made some changes, like it's not going to know about these changes. So so that's not great. I mean, it's great because it's one of the cool things about Bazel is that it has this kind of facility to figure out has something changed if you give it the correct information. So what's happening here is that I have my file here. It's called my awesome output, and the purpose of the file itself, purpose of the rule, is to take in this file here, and it's supposed to write it into another file. So let's see what happens if I change this file now. So this is a cool change. Okay, so if I run this again and I take a look at my output again, so now I have my input file here has some different information, but Bazel doesn't know about it. So Bazel is just saying, oh yeah, nothing has changed. Like here's something that I made earlier. Yeah. Here's something that I made earlier. You can use that because, as far as I know, nothing changed. And this is another thing that took me a little bit of a while to figure out, and I got some really good help on the Bazel Slack channel here. So all we really need to do here is we need to tell our action here that we're running that there is an input. There is a list of inputs that Bazel is supposed to keep an eye out for. And we do ctx file my input file here. So just by adding this inputs array here, the action is going to check is the input file that we defined earlier. So if we take a look at our definition here, the input file is being passed in here. So just by adding this into our rule, it's going to check. Is my input correct? Or is my input, like, do I actually have do I have an artifact, or do I have something cached based on this input here? And if not, I have to run it again. So if we run this again, let's see, I probably made a mistake. Yeah, this is the mistake that I make every single time. So there's supposed to be a comma here. So we run this now, and now when we take a look at our file here, the output file here, this is a cool change is there. So we run it again, nothing happens because nothing has changed. And then I can go in here and I can just make some random changes to it and run it again, and then it had to run it again. So basically what we've done now is that we've created this this custom rule. We declared an output file here, which is called just out file name, and we created an action, and the action, we tell the action that this is the output that the action is going to be producing. This action depends on this file here, so it always needs to check are there any changes inside in the files that I'm passing in as inputs. And then we define an executable. We say I'm pretty sure you're running on Windows, and I'm pretty sure that you have CMD on the machine. And then we just create our build command here. And then we just tell the rule then just says we're going to return, there's a file that's going to come out of this, and this is the file. And this actually allows us to use the file in other steps, but I'm not going to go into that right now. So another kind of cool thing that we can do now is, because we've created this this rule, we can duplicate this, and we can make some other ones. So I can let's just duplicate this here. I'm gonna change the name into write something else, and let's just use the same input file, but let's say that the output is going to be something else. So now I'm using the same function here. Write new file. I'm giving them like different names. They use the same input file, but the output file name is different. So now, if I run, for example, Bazel build all here at the bottom, let's see, all, then we should see something really cool, but nothing is happening. Right, something else. Okay, so let's do Bazel, just Bazel clean, and we do build all. All right, so we find 2 targets, and the 2 targets, if we take a look at here, yeah. So here we can see that I have 2 files, something else.txt and my awesome output.txt. So yeah, this is basically the basics of just how to make a rule and how to make these kind of super simple. Yeah, I mean the basics. I mean everything on top of this is just kind of customization, and for me, when I was learning this is kind of the information that I felt like I needed to kind of understand and master to be able to continue with this. So the last thing that I want to do is I want to make this, I wanted to highlight kind of 2 of the things that make Bazel like really powerful. One of them is the kind of the caching and figuring out kind of the dependencies and making sure that only the stuff that needs to be built is built. And we did that here, where we defined the inputs that if the file here changes, something like this, it's going to trigger regenerating everything, because both of the rules know that they need to check both of the actions need to check and get invalidated every time that this file changes. But one of the things now that I don't like about this here is that I'm making some dangerous assumptions that the user is running on Windows, the user has CMD installed. So that's the other kind of really powerful thing about Bazel that I really like, which is that we can actually use this workspace that we have here by just loading in the tool that we need, to be able to run this command. So and just to make this a little bit cooler, I'm going to jump into the Bazel, the Python rules here. What we've been doing right now is that we've effectively just made some. We've just been making, just using something on my computer. But the cool thing about what Bazel allows you to do is that it allows you to basically create an environment, almost like a sandbox environment, where I don't have to worry about if the user has CMD installed or if they have Python installed or whatever. So I'm just going to quickly show how to do this. So the Python rules here are really cool. In the documentation, getting started, it actually tells you that you can just copy paste. I really like just copy paste blindly into my project, but this code actually doesn't work anymore. So we need to go in here and go into the latest. The latest is going to give us the workspace setup again. So we'll just copy this code here back into our workspace. And what's happening here is that we're loading in the HTTP archive kind of module from Bazel Tools, and we're defining an archive called rules Python. And this is going to give us a Python version. So you can check this out in the documentation, in the documentations themselves. I'm going to go and scroll down a little bit further here, and I'm going to take this here. So I'm not going to install. I'm just going to go here. I'm just going to load the Python toolchain in here. I'm going to use Python 3.9, and I'm going to register the interpreter. So I'm not going to use pip parse in this video, but you can take a look at there. I have another video that shows how to do that. But that's a little bit beside the point. So I'm just copy pasting it in here. And basically what I've done is that I've loaded the Python rules. I have a Python toolchain, and I'm registering the Python 3.9 kind of tool chain, and then I'm loading it as an interpreter. So the last thing that we need to do here is we just take this code here. It's using it. So we've added a new package called Python rules, and that gets downloaded from the internet. So now what we can do in our build file is we can just load in from the Python rules package. So the @rules Python means that we're loading it from the rules Python package. The @ symbol means that this is a package. And then I just copy paste this. This is loading a rules file, so BCL, exactly like we did. And we're loading a rule that's called PyBinary. And then I pasted the example code for the PyBinary. It's called main, and it takes in, it needs to be a name, and it takes in a source file. So I'm going to change this to my build tool, and I'm going to make a Python file, call it my build tool.py. And to start with, I'm just going to do print this is my build tool. So now I made a really simple build tool. So I'm saying that the my build tool has a source file. It only uses one source file, but it's called my build tool here. So what I can do now is I can do Bazel. I can actually, because this is a binary file, I can do Bazel run, and I do the same thing, // for root, semicolon for project, and then my build tool. So I can now run the Python binary that I just made, and let's just see what happens. First thing that happens is that it downloads the Python interpreter for me. And if you're running this on a computer where you're not sure what Python is installed, or you need to ensure that there's a certain version, for example, installed, this is a really good way to do it. So now you can see that it printed out, this is my build tool. Awesome build tool. So let's see, quickly go to my notes here. Okay. Let's see. Now I need to build. I need to make a build tool, and actually I thought I had it saved somewhere. All right. So I don't have it saved. So I need to just really quickly remember how to do that. So we go into our build tool. So first thing that we need to do is we need to, for this build tool, I'm going to define two inputs, and the inputs, I can never remember how to do this, so I'm just gonna really quickly Google it. Python, how to get input from command line. So this is done not like there, so I think it was done like this. Here we go. So first input is going to be, so the first input we're going to be using is going to be our source file. And then we do second input is going to be our, target file. All right, so just while we're testing it, this wasn't really supposed to be about the Python. I'm going to do this as fast as I can, but here's a really good one. So good thing that I can do. So Bazel.exe run when I'm testing, because eventually we're going to be passing this into our build tool. But if I do 2 dashes here, I can actually put in arguments. So I'm going to take the absolute path, because I'm testing, I'm going to do an absolute path to the, as the first argument to my input file. And I'm going to do an absolute path to my output file.txt. So we run this. It's a little bit slower than running just normally with Python, because it has to do a build every time that I run it. So it's probably pretty easy to debug this. Yeah, I think it's supposed to be like this. Let's see. So it would be really, yeah, here we go. Okay, so now I have input number 1 is my input file and output is my output file. So let's just really quickly we open source equals open source file. Not a Python tutorial. I'm not the greatest Python programmer. So this is going to be in data, and that's going to be source.read. And we do then close, and then we do target equals open target file read. This is supposed to be read, and this is supposed to be write. And then we do target.write in data and target.close. Here we go. So let's see what happens if we run this. We should be seeing an output file appear here in our project when this finishes running. Here we go. So we have my output file, and yeah, so basically now we have a Python tool or a custom build tool that takes 2 arguments, 1 input and 1 output. Just for fun, we can do output equal, let's do out string equals in data.upper, just to show that we're actually modifying it. We run this again. So it's this is just the absolutely most simple kind of build tool that you could be doing. I mean, you're obviously going to be doing a lot of other kind of cool things, and basically the Python implementation, the Python rules are really cool. You can have these Python libraries and cool things. All right, so let's make a new custom rule that uses our build tool. So I'm just going to copy paste the definition for this rule here. Here we go, and I'm going to change the name of it to write new file with custom tool, and I'm going to make the implementation be called the same and I'm going to copy the implementation, just duplicate it like so, and then we can go ahead and do it like this. So basically nothing has changed, so we've just made an identical build rule, but we're going to extend it so that we can use our custom build tool. So yeah, so the way that we do that is first off, we're going to load our new build rule into our build file. And just double checking what it's called. It's called write new file with custom tool. We add it in here. And this means that we can make a new kind of rule, give it a name called build with custom tool, and it takes in the same arguments, and like so, and yep, here we go. So let's try this out. We do Bazel build with custom tool. Cool. Nothing's changed, so we're just getting our yeah, it just works exactly the same way. So what we need to do now is we need to pass our build tool into the into our new custom rule. So this is the new rule that we're making with the custom tool. So we need to add another attribute here called my custom build tool, and that's a label as well. Label, but this label needs to be flagged as an executable. So we say it's executable as true, and we say that it's I actually don't know exactly why this is needed, but now we have now we can pass in this custom build tool into our new rule here. So let's go in here and take a look at our build file. So here we go. We add another. Let's double check my custom build tool. we go here and we say the my custom build tool. So because it's an executable, we can actually just pass in our Python binary here, because behind the scenes Python binary, or the Py binary, is actually making an executable for us, which is why we could run it earlier. So all we need to do now is we just say this is from the root of the project, from a package, and we say my build tool here. So we build it again. And nothing new happens because we're not really using the custom build tool yet. So now all we have to do is we have to go here under this write new build tool here. Instead of the executable being cmd, we say ctx.executable dot my custom build tool. So then it's going to use our custom build tool here. And we are going to give it an argument. The first argument is going to be the input file, if I remember correctly. So just take a look. Yeah, the source file and the target file. So first argument is going to be the path to the source file. Second argument is going to be path to the output file. And let's just see what happens. So because we're building this now, so you can see that now this executable is actually a dependency. It's actually a dependency, so it had to check: do I have this this tool actually built? And if I don't, then I can build it. So now we are using the custom build tool that we just created, and let's take a look at the output. We go under output here. So the output that we passed in here. Let's take a look at what we called that. So it's actually being called something else. Here we go, and let's just to be completely sure, let's do a clean Bazel clean. Then and that's also going to let us see what happens. So build. We do Bazel build with custom tool. First thing it's going to do, it's going to figure out that it needs to build my build tool, the binary file, and then it's going to write into. So it's going to write into the text file that we defined, and the text file here is called my awesome output. And as you can see, that this is all capitalized. So yeah, this is how we can make a really simple build tool. So and the key here is that we've actually now made this hermetic, which means that now it doesn't really matter on which machine this is going to run on. This could probably maybe run on Linux and on Mac OS, because the Python interpreter the tool chain that we're using, that we got from the Python rules, that works for all of the different platforms. So one last thing that I want to show that I thought was really useful was you can do, let's see, there's a command, Bazel, instead of doing build or run, you can do a query or action query. And if you do that, this is going to give you a bunch of information, really useful information about the action that you're running. So here you can see, for example, these are all the inputs, but the interesting thing here, kind of for debugging, at least in the short term, is here it shows the command line of what I'm running. So here we can see that we have mybuildtool.exe. This is the executable that we're running. It takes in the input file path, and then it takes in the output file path as well. And this is why it's this actually gets outputted. This is actually how it works. So this is a really useful tool for debugging. So I think we've accomplished everything that we set out to. So I hope this is useful for someone.